So in the previous video, we discussed about how there's increasing amount of data and the complex data that we are gathering, and which makes our analysis more and more complex, and how a laptop and desktop is inadequate to provide enough resources to perform effective analysis. And towards the end, I left you with a thought about how to go further, how we can get more and more computational resources. And the crude idea was like buying different high configuration desktop machines and integrate them to behave as a single unit. So this particular slide, we'll think about that, basically venture that idea a little bit more in detail. So this one we'll talk about really the basic components that are integral to the part of a high performance computing cluster. So the main idea, so this is again pretty much the idea which I left you in the previous video, was like buying these high-end desktop machines and integrating them to behave as a single unit. And that's pretty much is the definition in terms of, if you like to, definition of what a high-performance computing cluster is. So high-performance computing mostly generally refers to the practice of aggregating computing power in a way that delivers much higher performance than one could get out of a typical desktop computer or a workstation in order to solve large problems in science, engineering, or business. So let's go and look a little bit more detail about what it means, but this is pretty much a same representation of the previous concept that we are having high-end config desktop machines being integrated together to behave as a single unit. And the right side image, what you are seeing is an basically picture taken of a real data center, and you can see these are the different machines, different desktops which are lying on their belly or on the side, and they're being integrated to behave as a single unit. That's how a typical data center would look like if you visit it. But there are other solutions out there. I'm not really trying to put that this is the only way of actually acquiring a lot more resources, but there are other ones. But generally, most common one is this particular type. Okay. So from a bioinformatician and user perspective, what are the key components of a cluster? And for me to explain what are the features are and why they are relevant, what the best thing would be we go through a journey of actually building a small cluster. So let's say a particular research institute, based on the feedback they have received from the researchers or the grant money they have or the funds they have, they decided that they would like to build a small computing cluster which is based of 10 different desktops, and I will call them machines, but they're essentially the same. And based on the requirement, they thought of actually buying 5 of the machines with the configuration of 32 CPUs and 256 gigabytes of RAM. Another 5 they bought for 64 CPUs and 512 gigabytes of RAM. So let's say this is what they end up buying. So in generally, that's pretty much what you will see in regular HPC clusters, that there are different machines having different configurations. Generally, machines which has similar kind of configurations are grouped together and been given different names to these particular groups, and these are very arbitrary names. Here I'm calling the first one as low mem, and the second group second group from 6 to 10 I'm calling as high mem. These names are often has a technical term associated with it. These are called partitions or queues. You might interchangeably hear one of these particular name. So in this particular case, we have two partitions, low mem and high mem. Since these are these machines has the high amount of computational resources, so most of the analysis that happens on these particular machines. So these are referred as compute nodes. This is again a technical term, but that's what you'll hear about compute nodes having which partition. So partition is like which group it belongs to. So yeah, we build up this particular, let's say, bought these 10 particular different machines, integrate them. Now they're behaving as a single unit. And since it's built at an institute level or research or a university level, so we obviously expect there would be going to be multiple users. The question comes how we should let these users access this particular compute node. So this is a small cluster. It will be a disaster if you let everybody just simply walk into and start using it. So one of the things is security risk, high security risk. The second thing is there is no coordination in terms of who is using which compute node and where. So that's why what generally in practice is there is an additional machine put in the front end of the rest of the cluster, and this front end machine is often referred with different names. You might hear it as a head node, login node, or submit node. They all mean exactly the same thing. This is a front-end machine. This front-end machine has two distinct purposes, have many ones, but the ones really crucial from a user perspective. First thing is it checks user credentials. Now what we do is in a cluster we give each user a username and password using which it try to connect to the cluster. So whenever you're trying to connect to the cluster, the first thing user does is trying to connect to this particular login node, and that's where you provide your user credentials. And once you provide correct user credentials, you're let into the system to use the resources which are on the compute node. The other purpose which is associated with this head node is to run a resource management and job scheduling software. Now this software is very different depending upon what cluster you are accessing. Some clusters have Slurm, which is simple Linux utility and resource management software. Some has SGE, which is SunGrid Engine, PBS, Portable Batch System, Torque, and many other ones. So this is really crucial. So if you're trying to access any cluster, the first thing you need to understand is what kind of resource management and job scheduling software that is running on that particular cluster. Based on that, you will be using different set of commands to access the resources. And in Slurm, those commands are different. SGE is the commands are different. There are equivalent commands between them, but the way you of the name of those commands are a little bit different between each kind of resource management and job scheduling software. So what does the resource management does? The resource management keeps a track of how many resources are available on each of the compute node. So let's say if I start using compute node 1 and I submit a job, or basically I ask for resources like 12 CPUs and 100 gigabytes of RAM, the resource management software keeps an account that a particular user is using 12 CPUs and 100 gigabytes of RAM, and another 22 CPUs and 156 gigabytes of RAM is available if any other user wants to run it and meets that particular requirement or smaller than that particular requirement, he can run the job over there. That's the resource management does. The job scheduling part is like there are different users. Everybody wants to get their data analyzed first. So how does it work? So basically it's first come first serve basis. So whoever submits the job first gets the resources first and they get analyzed on the server first. But those can be changed and mostly done by the system admin if they set up different kind of queues. We talk about compute nodes where main analysis is going to happen. We looked into the head node, what its purpose is. But then we haven't talked about where actually our data sits in it. Where if I am trying to move my data in this cluster, where would my data would be? So data devices are generally an external. They are not associated with any particular compute node or any kind of submit node. These are external devices. So your data stays on your data storage devices where your home directory would be, your labs directory, your projects directory, depending upon what architecture is there in your cluster. When I mean by architecture is what kind of folders that are provided by your system admin in order to put your data. That will be different between different kind of clusters, so you have to check with your system admin if you're using a different one than Xanadu. The two distinct advantages of data storage devices being external. One, if you at any time if you want to increase these storage devices, we can just buy another data storage device and plug in and increase the basically the capacity. The other thing is these data storage devices are connected with respect to your head node and all the compute node with the same speed. So now you don't have to perform your analysis on one particular compute node thinking that there is a faster access from that particular compute node. No. The access of your data from any of those compute node is equally efficient from your data storage. So you can run your job in compute node 1 or compute node 10 as long as the resources you are asking are existing on compute node 1 or the compute node 10. So from a user perspective, these are the 3 or 4 different key components you should be aware of. One thing is what are the different partition or queues that are there on your system, and also you would like to know what is the each of queues, why they are grouped in a particular fashion. The second thing is it's important to know what kind of configuration in terms of resources are there on these different compute nodes. These are different partitions and queues we talk about. These are called compute nodes. Then we have a head node, login node or submit node, and has the two purposes. One is to check user credentials and another is to do resource management and job scheduling. And we also need to be aware that okay, our data storage devices are external and they're connected with the same speed with pretty much all of our compute nodes. So there's no generally preference that we should be using one versus the other as long as the resources are available on both of those ones. So these are some of the key components or terminologies you will come across when you're trying to use a high performance computing cluster. Now, this is the Xanadu cluster that we will be doing most of our hands-on exercise, or wherever I will be doing most of the demonstration of different concepts. And this is the configuration. So Xanadu cluster runs on Slurm. We have different partitions, and these partitions again grouped based on certain properties associated with them. So the first one is belongs to Xeon partition because they have Xeon processors. The next is AMD based processors. Then we have certain compute nodes which are called high mem partition, primarily because they have a higher memory, and this may change ranges from 500 gigabytes to 2 terabytes. We have two compute nodes called MCB. The purpose of those ones are mainly for training or running courses, teaching courses. We also have certain GPU nodes just to facilitate any application that explicitly needs GPU cores for performing analysis. The first Xeon and AMD partitions has also another partition associated with it called general. They both belong to general partition, and it's quite common. In terms of Xanadu cluster, the login node, there are three different nodes I want you to be aware of. One is Xanadu submit external, and the second is Xanadu submit internal, and there is a transfer node. Xanadu Submit External is accessible from anywhere outside the Yukon Health network. Whereas if you want to try to connect to Xanadu Submit Internal, you have to be within the Yukon Health network. If you're trying outside the Yukon Health network and you still would like to connect to Xanadu Submit Internal, then you have to use a VPN in order to connect to Xanadu Submit Internal. These two submit nodes are in place for researchers to connect to Xanadu cluster for doing their analysis. However, the third one, the transfer one, is in place for transferring data in and out of the cluster. The data transfer is disabled on first two submit nodes, which is Xanadu Submit External and Xanadu Submit Internal. Primary reason is because while transferring the data, it sometimes clog up the resources and the users cannot get into the system. So that's why there is a dedicated node for transferring data. Then data storage devices is again possibly if you have we'll look into those ones once you connect to the cluster. But this is what overall the Xanadu cluster looks like. So key things to remember about Xanadu cluster is it runs on Slurm. As a resource management and job scheduling software, there are different partitions. The main partitions are Xeon, AMD. If you're doing regular kind of bioinformatic analysis, if you're doing mostly like memory intensive, then you're possibly looking into the high mem partition. MCB student partition is explicitly or basically in place for teaching purposes, and GPU nodes are available if you need a GPU for your analysis. So in a whole, what we're trying to do by an HPC in place is by having decent size these compute nodes or decent size these machines and integrating them so that it mimics a much bigger system and provide us enough computational resources so that we can do our analysis. So this is pretty much it. There are some additional features with respect to the submit nodes. I will talk about those ones in the next video.